students, welcome to the course on Statistical Methods for Psychological Research Part 2. In this lesson, we are going to learn how to determine a formula for T in testing the difference between two dependent means or correlated means. What are you going to learn in this lesson? Let us look at the learning objectives. Learning objectives. The assumptions and properties for the two sample correlated means with its probability distribution, to examine dependent sample test and its suitable conditions with applications, to study the sampling probability distribution for the two sample correlated means. Let us start. We will begin with the first part of the lesson, which will introduce you about the assumptions and properties of sampling distribution with the difference between two dependent means. Students, there are several assumptions to be considered which are important for conducting a valid statistical inference for the two sample dependent test. Assumptions. Dependency. The first assumption comes under dependency. The observation in each pair should be depend on each other. The measurements or data points in one pair should be influenced by the measurement in the another pair. Violation of these assumptions can lead to a biased result or unreliable results. The second assumption comes like normality. Assume that the paired observations are drawn from the population for the sampling distribution of the difference between two dependent means. It follows a normal distribution. This assumption is particularly important when the sample size is little small. If the data deviates significantly from normality, it may affect the validity of the statistical test. The third assumption comes as homogeneity of variance. The variance of the dependent variable should always be equal. In other words, we can say that the variability within each pair should be similar across all pairs. There should not be much deviations or differences. Violation of these assumptions, known as heterogeneity, can lead to biased or inefficient estimates can be done in the statistical test. The fourth assumption is paired observation. The dependency means should be based on paired or matched observations. Here we consider only a pair of items, what we call as where each pair consists of measurements from the same subject or unit. Here the pairing is typically done to control the individual differences or other sources of variability. It is important to assess these assumptions before conducting any statistical analysis involving the difference between dependent means. Various statistical tests and techniques such as pair t-test, ANOVA has assumptions related to these factors. If the assumptions are violated, alternative methods or adjustments may be necessary to ensure the validity of the analysis. Now we are going to study about the properties. There are several important properties to be considered when considering the difference between two dependent means in a sampling distribution. Central limit theorem comes into the first picture. If the sample size is large enough to check the sampling distribution of the difference between two dependent means, which tends to follow a normal distribution. When the sample is large enough, we say that the sample will tend to central limit theorem. That is what we try to say in this slide. In inference statistical test, this is another important assumption we also keep in mind whenever we are applying the statistical test. Means of the differences. The sampling distribution of the two dependent sample means is equal to the population means. This property allows us to estimate the population differences based on the sample data. Variance of the differences. The variance of the sampling distribution between two dependent means depends on the variability of the individual observations. The formula for calculating the variance of the difference depends on the specific statistical analysis being performed based on the variances. The standard error. The standard error of the sampling distribution represents the standard deviation of the distribution. It provides a precise measure of the estimated differences. A smaller standard error indicates more reliable estimate. Confidence intervals. The confidence intervals can be constructed to estimate the range within the true population differences are occurred. It may be a interval or it may be a point. Here the width of the confidence interval or determine the sample size. Whenever we talk about the width of the confidence interval, it means we talk about interval estimates. Here, the variability of the observation and the desired level of confidence may change from different test statistics. Hypothesis testing. Hypothesis test can be conducted to determine whether the observed difference between the mean is statistically significant or not. We have seen lot of hypothesis testing about null and alternative hypothesis in the early videos. Here, the test statistics involves comparing the observed and expected differences under the null and alternative hypothesis. These properties guide the analysis and interpretation of data when comparing two dependent means and help us to draw a meaningful conclusion about the population from which the samples were drawn. Consider an example to illustrate the concept of sampling distribution with the difference between two dependent means or correlated means. Here goes the example. We wish to investigate the effectiveness of the fitness level of sports person participating in a new exercise training program. Here we are considering the difference in the fitness level of sports person before and after the training program. The following data is related to the fitness level measurement. It is given as in arbitrary units for a hypothetical group of 5 participants. Here I taken 5 participants before the training program, what is their fitness level, after the training program, what is their fitness level, which are given as a pre-program and a post-program. The values are listed here. For participant 1, it is given as 60 and 65. For participant 2, it is given as 55 and 62. For participant 3, it is given as 70 and 78. For participant 4, it is given as 75 and 80. And the last participant 5 is given as 65 and 70. Here, we are given the difference between the means of the pre-program and the post-program measurements are given below. For the 5 participants, the difference between pre and post are listed down. Here, we can calculate the estimate of the population mean for differences and the standard error. Here, the estimate of the mean difference is given by the difference divided by the number of observation, that is equal to 6. Now we are going to see what is standard error and how to calculate that. Here, calculate the standard deviation of the differences. In this case, it is obtained as 1.7889. With these values, we can construct a sampling distribution to assess the particular difference between means. Let us summarize what we have learned in this lesson. In this lesson, we learned about assumptions and the properties of sampling distribution with difference between two dependent means or correlated means. I hope you can understand all the concepts very clear. We will continue in the next video. Thank you.